Hi, hello, welcome to this particular interesting session where we are gonna explore about organic chemistry. Welcome back, and we are after a pretty long time we are posting it out, and we are so thankful for all the subscribers we have gotten. Thank you so much, and keep us supporting. We are going ahead, and we are again, reproducing our videos. So if you guys really like our work, right, what you have to do is like, share, and subscribe as others, as is being told by others famous YouTubers like this. And then, what we are going to do is basically we are going to explore in this particular session about organic chemistry. So this is a very level zero organic chemistry. So if you guys are in grade 10, 11, 12, or in 9, or in some other grade, who wants to really understand what the organic compound is and how do you name this particular organic compound, this is the first, level zero lecture, which will help you to understand many of the things. So without any further delay, let's go ahead and let's quickly start off with today's session. That is naming of organic compounds. How do you name it? It's pretty interesting and there is a logical sense to it. Right. We will not talk more about the reaction. So I'll cover that up in the other video, right, which I'll be posting soon. So make sure that you guys go ahead and you do the subscription, press that bell icon, and like this video if you guys really like it. So we are going to follow this entire curriculum in this particular video. You can go ahead and you can skip it. We have marked that on the timeline, so you can just scroll, left, right, whatever section you want us to, teach you. So this is EdTech 2.0. This is Crack It. This is Pikai Sarkar, and let's go ahead and let's start out with the first topic. That is basically the representation of organic compound. Now, before we go ahead and before we write down the name, it's very important that you go ahead and you know how does this organic compounds are represented, and how do you go ahead and how do you um, write down or showcase that you are talking about this particular organic compound. So for that, we have four different varieties how we represent it. The first one is being the most common is to write out the molecular formula, wherein you go ahead and you just mention that there are these many number of carbon atoms. Then here you go ahead and you have your H8, so eight hydrogen atoms, and then you have oxygen. This does not talk that much about what kind or what variety or how the arrangement is there inside the atom, because that is what has been most important in the organic chemistry. Hence, we move on to the condensed formula, which you guys will be much more familiar if you guys in your grade 10, 11, and 12 and doesn't know about the organic chemistry that much. So this, which you go ahead and you understand is basically you have a proper idea now how the arrangement of atoms are there in this. And from this particular formula, you can easily go ahead and easily can understand that, okay, fine, this is what the arrangement looks like, and this is how we are going to take this up for the reaction. Now, moving on to the next one. So, the next one here we have is our displayed formula, wherein we are in much more detail we are showing the connection. So in grade 10, this is the most common form which you can see your questions would be from. This is pretty much very much easier also to go ahead and to identify what is connected to what. So here, for example, you have COOH, that is, you must have identified by now, this is a carboxylic acid group, right? Now this particular, all the three arrangements are fine up till grade 10. But as we move on to your 11th and 12th, we move on to our next variety, that is skeletal structure, or also called as a bond line formula. So in this particular case, you don't write down where the carbons are. Instead of this, you create corners. You create this edges, you can say, right? Edges or you can say vertices, right? So all of this point, these points are basically representing a carbon, and you assume that wherever you have not mentioned that the valency of that particular carbon is not satisfied. For example, for this one, you have two of the hydrogens which are filling in for it, right? And we don't write our hydrogens here. And with this, you need to understand. You always remember that carbon forms a tetravalency, so four valency, right? So here you have one and two of them which are represented, and two of them are hidden. So there are two hydrogens which are attached to that. If you talk about this particular carbon, it is already double bonded and a single bond here. So you have already tetravalency which is fulfilled. So it will not form any hydrogen There is no hidden hydrogen over on this particular carbon. And on the contrary, here you'll have three. So this is how you have to read it, and you have to be very much comfortable in doing so, because this is how you have solved most of the question. And in the real life, you don't really have to have that much amount of time to represent or to write down in the displayed or in the condensed formula. So in most of the cases, you should be comfortable in this particular. The fourth one is what we guys are targeting at. Now, moving on from this to the nomenclature, the basis of the nomenclature of organic compounds. But before we go into the nomenclature of organic compound, let's take an example and let's try to, add that up and try to understand that how do we write down any nomenclature? How do we write any name? So, for example, let's take my name. So, my name is Mr. Pikai Sarkar. This is how you're gonna go ahead and you're gonna represent, right? So, if you observe very closely, there are three different parts to it. One is basically your prefix. My Mr. is my prefix. Then you have Pikai. That's my first name, right? That's what my friends will be calling me by that, right? So Pikai. And then we have our surname, that is Sarkar. Then, where we have the professional things, you to go. So there you have your Sarkar as your, Mr. Sarkar is what they might, go ahead and represent. So there are three parts to my name. Now, if you apply the same thing in case of organic chemistry, what we say is the prefix is the one which is here, Mr. for me. In organic chemistry, they have for the compound, it will include all the substrate. So whatever the branches it has, the main carbon chain has, whatever it is attached to it, which are non-prioritized functional group, I would say, or non or branches, whatever are leaving from that particular main carbon chain. This is how you go ahead and how you name it out, right? So this is what we call as a prefix. So it appears before the name. Now, moving on to the next word, that is my first name, that was Pikai. Here, in case of organic chemistry, that would have been your called as your root word. That's the root how you are gonna call me out. So, in this, in organic chemistry, what you gonna see is that organic this root word represents the number of carbon you have in the main carbon chain. Now, how do you go ahead and how do you select that main carbon chain is what we're gonna learn in the later part of the video. Now, moving on to the last part of the name is basically you have suffix. So, suffix is nothing but the surname, right? So, here in this particular case, my suffix would be Sarkar. And you can go ahead and you can write down your prefix, suffix, and root word in the comment section if you want to go ahead and do that. And if you have understood that thing, right? Okay, so now if you have understood about the suffix, so suffix is basically nothing but the main functional group, right? The prioritized higher priority. So in that entire, if let's say a particular organic compound has different groups attached to it. Now in that, which one is the main part which you have to represent? That highest prioritized order of the functional group is what we are gonna call as your suffix. Now, what is functional group? Let's go ahead and let's try to understand that after we have understood the naming, how, what is our root word. So let's move on to the next topic of naming the organic compound. Now, while naming it, as we focused, right, as I said, that Pikai is the root word for mine. Similarly, in case of carbon also, in the main carbon chain, the total number of carbon, whatever it has in the main carbon chain, that is basically called as your root word. Now, here in this particular example, we have just one carbon, right? And hence we are going to use the root word for that as meth. So, in all of the hydrocarbons where you have just one single carbon atom, you gonna use always the word as your meth. So it can be methanoic acid, methanol, methanol, and here of course you have methane gas. So this is how you're gonna name. Moving on, if we gonna have two carbons, then we gonna use the root word as your ethanol, ethanoic acid, ethanol, right? And then of course you have ethane over here. Similarly, if you move on to the third, if you have three carbons, then you call that as use the root word as your prop, right? So you have propane, which is given in here. Then you have propyl, propine, right? Propene, propanoic acid. So there are many props, compound which are possible and which we are going to explore further and further as we move ahead. Now, moving on to a particular list from the perspective of grade 10 and grade 11 and grade 12, you guys need to learn up till your 12. 12 is more than sufficient if you know for that up till your school days. Then, of course, after that, you might require to have and work with, where you have more number of carbons. So you can go ahead and you can always come back to this video to have the reference. Now, here, there is a very simple trick to go ahead and to remember this. So you need to just memorize for the first four. You have meth, eth, prop, and but. Then after that, what you have to just follow is basically for a regular hexagon, a regular polygon. So here in this particular case, you have pentagon, right? So you have pent five. Then you have hex, your hexagon, so six. Then you have heptagon or septagon as your seven, and then you have octagon, and then you have nonagon, and then you have a decade. Right. So this is how you have gone, you have named it. So all of that, decon, nonagon, octagon, right? So all of this go on. If you replace, if you just take the first word, first letters of that, first few alphabets of that, then you are good to go and you will remember up till 10 very easily, right? So what I request you to remember that first four you have to remember, then after that it's regular polygon, right? From there, from 5 to 10, right? For 11, you have undeck, right? Undeka. So that's un is basically one, then you have dodeca, then that's two, right? It's pretty simple forward. Now that brings us our discussion to a very important question. To understand the entire of organic chemistry is that you have to understand what do you mean by functional group. So here in this particular case, in case of your functional group, it's pretty simple to go ahead and to understand it. It's like just like the essence, right? So for example, you go into pastry and you look on to different flavors. So for example, you have chocolate flavor, you have strawberry flavor, you have lemon, you have orange, you have grape, you have vanilla, right? Pineapple, right? All of the pastries what you might have had where you had might be they have manufactured using essence. So in most of the cases, whenever you're going to a bakery shop, they're using essence rather than using the actual fruits, right? Now those essence are nothing but your chemicals. So just like those chemicals give a particular flavor, a scent, a taste of that particular gas or of that particular food, might be of grape or chocolate. So exactly in that particular fashion sense, functional groups are also those flavors which are being added to the organic chemistry. Now, if you have to formally define it, so then you can say that it is a special type of atoms which are going to be present in the molecule and which gives it a unique personality, unique taste, unique smell, unique physical property, unique chemical properties to that. And why do we gonna learn about it? So that whenever we are encountering the same functional group, you are just be sure, okay, this functional group has these properties associated with that, so this particular compound should have these qualities which are associated with that, because it is really impossible to know about all the organic compounds as we speak, right? Now, so as we have just said, so they are basically used to determine what kind of physical and the chemical property that particular organic compound will be following it. Now, moving on to the practical use of the functional group, where we have seen the practical use. So now looking at this particular, slide, I'm pretty sure brings back, lots and lots of terrible memories of pandemic where we were closed, but this is where the real life usage of these particular things come into play. So for example, you might have heard about that you might have alpha variant, then you have beta, then you have delta, gamma, then you had delta variant. So there were many variants which were running across of coronavirus. Now, when you have to create a vaccine for these kind of viruses, what is the most important thing is to understand what are the chemical composition of it. And the chemical composition, the chemical properties are determined by your functional group. Now, this alpha variant, this beta variant. So, when you are preparing the vaccine, what you guys look around, which are the functional groups which are staying constant throughout the variants? And if you can, use or manufacture a vaccine which are targeting those particular functional group, then you are through that particular vaccine will be still be effective for that. So there were many of the videos discussion which you might have heard, learned, yeah, that this is different, this is effective this much, this is effective that much. It is all basically targeting the functional group which are attached onto that spikes, right? So now, since we have understood this thing, now let's go ahead and let's typically define what do we mean by functional group. So typically it is composed of specific atoms which are basically bonded together in a particular variant arrangement. And when you talk about, which are the other elements, which elements generally does it have? So you have your carbon, hydrogen, oxygen, phosphorus, sulfur, nitrogen, chlorine, fluorine, bromine, iodine. So there are many of them. And all of these arrangement of that is basically, determining your functional group. Now let's move on to something called as priority order. Now, what do we mean by priority order? Is basically we have so many functional group, and let's say if a particular compound contains more than one variety of functional group, how do we name it? So to solve that, we have IUPAC who has given this particular order. Now, if you are from grade 10, you don't need to remember or memorize the order of it. But if you guys are from grade 11, 12, or anything above that, you guys need to learn the priority order of that. Now here, these are, what I'm displaying. What you guys can do is take a screenshot quickly, so that you guys remember the priority order of it. Now, these are your amides. These things are there, right? You have aldehydes over here. So these are the few important ones. So aldehyde, nitriles, then you have ketones, then you have alcohols, right? Then you have amines, and then you have ether. Then after ethers, you actually ethers from ether onwards. What you can understand, they are not given that particular priority. So these all of them, if you go ahead and if you see that here we are using the word as in, right? So that signifies that is placed after your alkenes. We will go ahead and we'll learn about the priority order in the next few lectures, might be probably. And if you want me to create an separate video, like, and leave a comment, yeah, that will help me us. You can also reach us. So if you guys, what we have observed now, this is an exam time, so you might have few certain questions, certain doubts to go ahead and to help you out. So what we have created a particular community. We will leave out the description at the bottom, wherein we are gonna go ahead and we're gonna discuss the doubts. You can leave us your questions, your queries, we will answer that. So the email ID is basically helpme.crackit, crackitnow@gmail.com. We'll be sharing that in the description as well. Make sure that you are taking that out from there. So now let's move on to the last part of this particular section, wherein of this video, wherein we go ahead and we combine all of the things what we have just learned. So how do you write down the names of it? How do you have learned that you have prefix, root word, and your suffix. How do you combine that, and how do you write down that particular value? So this is how we are gonna go ahead and we are gonna learn in this section. So here, let's take this as an example. So the first thing what you have to do is basically choose that particular carbon chain where you have maximum number of carbon atoms which are being captured. So here in this particular case, this would have been the longest carbon chain. But let's say you have an example where you have the number of carbon chain, as in both of the cases you are getting the same. So there can be two possibilities. So one, first look on to that particular carbon chain or select that carbon chain where you have maximum number of branches which are being taken out from that. And if that is again coming as to be safe, then it doesn't matter that from which direction or which one you choose. You can go ahead and you can choose any one of them. Now let's move on to your step number two. Now, in the step number two is what you have to number things out. And while doing this particular numbering, you have to always make sure, number one, the functional group, whichever having a higher priority, gets the least number. Number two is basically when you have functional group and when you have branches which are attached, the sum of all of them should be basically be the least minimum as possible. And third thing is basically always make sure that while doing this particular numbering, you are covering each and every carbon. Generally, there is a tendency that kids, miss out the first one or the last one. So make sure that you go ahead and you can select out the entirety of it, right? Entire carbon chain. Now, moving on to the third one, wherein we have now identified that what are the branches. So in this particular case, you have this as your branch and this as your branch. So what we'll do, gonna do is basically, find out what is how many number of carbon does it have. So here you have just one carbon. So you're using the root word as your meth, and since it is a branch, you're using the word as YL. Similarly, over here you have two carbons, so the root word for this becomes eth 2. For 2 you have eth. You can go and you can go back to the video and you can just check that out. So you have eth, and hence you have the name here ethyl, right? So YLB is being added because this is no, this is a substituent part, this is a branch part. So YL is generally added to all the hydrocarbon ones, so that to signify this is not part, this is not from the main carbon chain, this is from that particular branch you have around it. So that's why you go ahead and you number that out. Now, once, let's say if you have a prefix instead of having these particular case, you go ahead and you use the prefixes which are given in the table again. So make sure you go back and you check that out if you require help in that particular case. Now, moving on, once we have identified those things and once we have located, we have numbered in such a manner that you have the smallest sum of the locants in this particular case, what you have to do is basically highlight that, here. So here you had at one at three, one at five. So you write down 3-methyl and then you write 5-ethyl, right? So this is how you go and you assign the numbers. Once you are done with that, the next part is basically to write down or them into an alphabetical order. So here you have methyl. So here, whenever you're going ahead with the case of your functional group, sorry, the branches. So in that you need to consider the alphabetical order. So for example, you had, if let's say you have two of the methyl group, right, which are placed into. So here we will move on to now to the next part. That is basically we go ahead and we write down in the alphabetical order, right? Now in the alphabetical order, you have to, so here let's say you have methyl groups, right? So here you just have one. For example, let's say in a particular example, you have more than one. So in that particular case, you don't consider dimethyl. If you are writing two, so you will be using the word as dimethyl. So in that you don't consider that di wala d, right? What you're gonna consider is basically the M, right? In that. So here, if let's say you had dimethyl and you have ethyl, so you'll still consider M and E of them, and you'll be writing that accordingly in the alphabetical order. So here in this particular case, E comes before alphabetically than M. So while writing the final name, right, what you have to write is basically you'll write as your 5-ethyl 3-methyl octane. So this would be the name of this particular compound. Now, since we are have already done with this, what we are gonna do is basically we are gonna learn about few of the examples. Now, this is the time to go ahead and to test out whether we have understood things or not. So what we are gonna do is basically pause this particular video and try to name it, try to number this out so that you guys understand. So we have already done that. Try to write down the name of it so that you guys can go ahead and can understand. Once you are done, what you can do is basically play it. So for those, if you are, already solved it out, so let's go ahead and let's understand this thing, right? So here we have numbered this as 1, 2, 3, 4, 5, 6, and 7, 8. So here right now we have at 4, you have two methyl groups. Here you have an ethyl group, here you have a bromo, and here you have a chloro. So why are we not numbering in the opposite direction? Then the sum of the locants, what the sum of the branches will basically will maximize, and hence we're gonna avoid that out. So that's why this is the correct the way of numbering it out. So here if you have to write down the name, so alphabetically B comes first. So then comes C, then you have methyl and sorry, then you have ethyl here this particular part, and then you have methyl. So hence the name for this is 3 bromo, 2 chloro, 5 ethyl, 4 comma 4 dimethyl. So here since you are adding the word as di, because you have two methyl groups and you're mentioning both of the positions. So that is very much important that while writing the name, you mention all the positions, right? Now, moving on to this next particular case. So here again, pause it and try to answer it. And once you are done, unpause it. So here you have this as to be the selected as a high carbon chain. Now, in this particular case, if you look onto the naming of it, so again you have fluoro, so F. Um, Now here you have a particular case where you have uh, isopropyl, yeah, this particular group what we have added out, right? So this can be named as your 4 isopropyl, and then you have 2 methyl heptane. Now if you are not going ahead with this particular naming of isopropyl, what you can otherwise, if you have to go from the IUPAC name perfectly, so you can also write down this as your methyl ethyl. So methyl, right? So why? Because what you do is basically again consider this as a branch, and then you have sub branch. So this is a branch, let's say we have selected. So this would be a branch to that branch, sub branch. So what you can do is basically ethyl will signify that you have two carbon here, and at the first one you have methyl. So you go ahead and you write down instead of that, you consider methyl ethyl. Now in that case also, you consider ethyl E as to be the alphabetically one, and if you are using that, so that will come in front. So you'll will become 4 methyl ethyl. Then you have 3 fluoro, 2 methyl heptane. Right? So this is also how you can write down this particular compound. Now let's move on to few more examples wherein we are gonna go ahead and where we are gonna understand that how do we write down if we have a functional group. Now here in this particular case you have a double bond and you have halogens and you have a methyl group. Now among this, the highest priority is being given to the double bonds, right? So hence, irrespective of the sum of locant tools, here you have to first follow about the functional group. Right, so the functional group here you have a double bond, so that will be given the highest priority, and irrespective of that, we are gonna number this as your one. So here the name of this would have been so 1, 2, 3, and 4. So at 4 you have 2 of fluorine, so that there you go and you have your 4, 4 difluoro. So F from that, then you have at 3, you have methyl, so 3 methyl. So your M for that. So this is how would be your alphabetical order. And at the end, you have your root word, and then you have your functional group, which is present at number 1 position. So here you have 1 butene. Now use this particular, the same knowledge to go ahead and to write down the second of that, right? So pause that video and try it out. So if you have already tried it out, so what you have to do is basically you have to number it again from your you have again two choices. So now if you start from the left side also you get a double bond, from right side also you get a double bond. So here in this particular case you choose this one because so that you get a lowest number of the sum of the locants. So here you get 1, 1 2 dimethyl, and then you buta 1 comma 3 diene. So in this particular case, since you have two of the functional groups which are having the same priority, you start with the left one out. Now let's move on to the next example. So here now you have a triple bond. Again, triple bond and then higher priority. Pause the video and try to write down the questions of it. Answer for that. So now if you have actually done that, so what you have to do is basically you have to again number from the right hand side. The triple bond gets higher priority and hence the name would be 4 comma fluor difluoro 3 methyl but 1 ine. Right, so you have YNE whenever you have a triple bond in place. So here in the case of where you have your both double bond and your triple bond, in that particular case, now there is a twist. Now in this, what you have to remember, if you are writing, if you are numbering both of them, and if the numbering of both of them are actually same. So in that particular case, you get the priority order higher to the double bond. But in the case where you have double bond or triple bond, and in one of the cases you are getting a lower number, prefer that numbers. For example, in the case of this, right? So here in both of the sides, if you number it, you'll get the same numbers at your double bond and triple bond. Here, you'll give higher priority to a double bond, and hence for the name for this particular case would have been pent 1 in 4 ein. So 1 and then you have at 4. Similarly, on the right hand side, now here is the twisting part. From the right hand side, if you go ahead and if you number, so you'll get at 2 of this and 3, then you have 4. So you'll get at 2 and 4. So that's how the numbers will be 2 plus 4 will be 6. Now if you start the numbering from the right hand side, so here you'll get 1, 2, and then you have 3. So 1 plus 3 is a smaller number, and hence you go ahead and use number from the left hand side, and here you have the name as your pent 3 in 1 ein. So that's how you go ahead and you understand the examples. Now here you have for the different cases. So for example, here you have an amine. So that is NH2. If you are in grade 10, you don't need that, but this will anyway will be helping out in grade 11, so it's better to know about it. So here you have three of it and you have an amine. So here you'll write this as propane 1 amine, right? So or you can just propanamine, right? You can propanamine, so you can write down that also. Now similarly in this particular case you have two of that, so you get, here the word as your ethanol. Eth is the root word and all is basically for your alcohol. Now, in this particular case, this is also an amine, but in this particular case, you have at nitrogen, you have two of the ethyl group. You have two carbons, right? So eth, and then you have branches of YL, ethyl. So there are two which is at N. And here you have a double bond. So in this particular case, you write down, you give higher priority to amine. So from 1, 2, 3, 4. So at 1, 2, at 2 position, you have an amine. So that's what here they have mentioned. Then at 1, 2, 3. 3 at 3 you have ene. So they have mentioned 3 ene. And then you have 1, 2, 3, 4. 4 as your root word. So hence they have used bute. And an N position with nitrogen, you have two ethyl groups. So N comma N diethyl. That's how you're gonna name this out. Moving on to few more. So here you have C double bond OH, right? So this is not ketone. This is an aldehyde, and hence you use the word as al. So this would be methanol, or also as called as your formaldehyde. You have just for one, you use the word as formal, and hence your formaldehyde is the name for this. Similarly, for this, you have two carbons now, so it is called as ethanol. Al is the word again, what you have to focus on. To the remaining rest of that, these are your methanoic carboxylic acid. So understand the difference here: C double bond OH, and here you have C double bond OH, right? So it's you have two oxygen in this, you have just one oxygen in this. So understand the difference between that. Now again, in case of the previous one where you saw alcohol, that is just OH, you don't have a double bond, right? So you need to take out the mole, the value or the concept from that. So here you use the word as oic acid as the suffix. So meth is basically used that you have just one carbon. Ane is basically how this particular carbon in the carbon chain is bonded. So is have ane associated with that. So methanoic acid is how you go about it. Then the second one is here you have two carbons, so you have ethanoic acid. Now, moving on to the next part, wherein you're gonna go ahead and gonna describe about these two parts where you have esters. Now, in organic reactions, we're gonna do about discuss about the esterification reaction. But how do you write down that particular name? That's one of the most troublesome thing in your grade 10 if you are looking from that perspective. So here you need to understand, Vacha, that here in this particular case, the one hydrocarbon which is attached to this oxygen is which will appear in the form of alkyl. So ALK is basically replaced by that root word. How many carbons do you have in this particular side? And then on the other side, you have called as alkoxide. So here you include this carbon and you count down total number of carbon here, and then you write down or use that word. And here you have alkyl for this and for this alkanoid. So here the name will be alkyl alkanoid, right? So for example, if you have to carry forward, think about this name. So how many carbons are there on the right hand side here? So there are two, so you will be using as your ethyl. And similarly on the left hand side, how many carbons are there are two, so you can name this as ethyl ethanoate. Similarly, in this particular case, you have one, two, three, right? So there are three carbons to it, but they are attached in a different manner. So what you're gonna do, you can consider this as your one of the main subsidiary carbon chain, and then you have again a carbon branch which is attached to that. So you're gonna name this as your methyl ethyl. Just we have discussed in the earlier example also, right? So you have methyl ethyl, and then how many carbons are there here? One, two, three. Select the longest carbon chain. You have three. So you have prop. And at two, you have your position. So this would be numbered at one. This would be at two. So you have two of that. So you have two comma two dimethyl as this, that part would have been described. So you have first written as your this part, then you write down this part. So you have either you can write down, in this particular case as your isopropyl 2,2 dimethyl, or you can go with alpha methyl ethyl, 2,2 dimethyl, and then you have propanol. So these are the two ways to go ahead and about that. And coming on to the last part of it, if you guys think about that, it is just organic chemistry contains only what we have in our body, completely wrong. There are a few of the products, which I've just mentioned it out. Just an additional tip is basically, the naphthalene balls, which you generally use, that white color or the colorful ones. And then you have TNT. When you use TNT, you might have heard about it in this particular, reaction video when you have boom, right? So all of those TNT, all of that explosive is also considered as your organic substances. The organic substance, this particular thing, have become a little bit broader. So, and the definition of, and as we are exploring, it is going to increase more and more. So, thank you so much for watching this particular video. I hope you found it very much helpful. Remember, Crackit is basically your EdTech 2.0. Make sure that you guys go and you subscribe, and we are coming up with some revision courses at a very discounted price, giving you guys an early bird discount. What you have to do, is given in the description. Go and check that out. Up till that time, thank you so much for watching it. See you. Take care. This is Pikai Sarkar signing off. Bye bye.